We've launched and now have active over 1,500 satellites. The combined power of all the satellites is over 5 megawatts. They're capable of outputting about 30 terabits per second of data. Starting in August, we should have global connectivity for everywhere except the poles. It's really meant for sparsely populated regions, because our spot size, talking in terms of cellular, is quite big. So we're well suited to low to medium density areas, but not to high density areas. In the high density areas, we will be able to serve a limited number of customers. We recently passed the strategically notable number of 69,420 active users. And we're, I think, on our way to having a few 100,000 users, possibly over 500,000 users within 12 months. So I think it's growing rapidly, and we're continuing to innovate the user terminal and the satellite and the ground stations and sort of gateways and points of presence. I think we're operational now in about 12 countries, and more being added every month. So it's like I said, it's a nice complement to fiber and to 5G, and it's also, although we can't talk about those deals today because our partner's not ready to announce them, I think it can be quite useful to a lot of telcos for data backhaul. So just, you know, if people have cellular stations in remote regions, just using Starlink for data backhaul to their network can be a very cost-effective way of doing data backhaul. And then notably for Starlink, relative to, say, other satellite communication systems, we are at around 500 kilometers, whereas the geosynchronous satellites are around 36,000 kilometers. So latency for a Starlink system is similar to latency for ground-based fiber and 5G. So we're expecting to get latency down under 20 milliseconds. So you can still do, it feels very fast, like there's no lag. And you can play, for example, competitive video games on a Starlink system.
This is a very tough market, Elon. I mean, if we look back over the last couple of decades, it has been littered with failure. We go as far back as the 1990s. There are big names that no longer are with us. They've tried to make satellite broadband a success. You've also now got strong competition. The likes of Amazon and OneWeb are also now attempting to launch new satellite broadband projects. What is it that makes Starlink different to what's gone on in decades beforehand, Elon, but also with your new competition as well? What is it that makes you different?
Yes. Well, when I gave a talk a few years ago about Starlink, I was asked for what's my goal for Starlink, and I said, well, our goal is not to go bankrupt. Because as you point out, every other low Earth orbit communications constellation ever done has gone bankrupt. Now, some of them have emerged from bankruptcy, but let's just say the original owners did not benefit from those constellations. So, they've either gone bankrupt after. Most of them went bankrupt before even deploying their constellation fully, and even the ones that did deploy their constellation, they still went bankrupt. You know, now they did subsequently emerge from bankruptcy, but you know, and obviously companies like Iridium and Orbcomm are doing reasonably well today, but not for the original owners. So step number one for Starlink is don't go bankrupt. That is, and you know, then if we succeed in not going bankrupt, then that'll be great, and we can move on from there. But I do think from a technology standpoint, Starlink is quite different from prior LEO constellations in that the technology that we're deploying is very advanced. What happens often with space-based technology, somewhat ironically, is that it tends to be older technology that exists on the ground. So companies generally have been very conservative, so they've said, well, we want technology that's proven to work on the ground, and then we have to test it for years to make sure it's going to work in the vacuum of space with a higher radiation load and that kind of thing. And so the technology that's generally been launched into orbit has been older technology. And we took the opposite approach and said, we're going to make technology that is, in some ways at least, more advanced than what is on the ground. And we're just going to take a chance. And so we have probably fair to say are the most sophisticated, the most advanced phased array technologies that, to the best of knowledge, no one has. Not even at sort of military level has this level of sophistication with phased array technology. I think that's sort of quite important for a fast-moving LEO constellation, because the terminal, which is a user terminal that is also phased array, and the terminal on the terminal on the satellite, the antenna on the satellite, they're both phased array. So you can switch from one satellite that's moving rapidly overhead to another one, and do so at the microsecond level. So there's you can't tell as the system is switching over from one satellite to another. There's no change in latency or jitter from one satellite to another. And a single satellite can illuminate many different user cell spots on the ground. So it's a digital phased array system. So we can continue to program and reprogram the system to greater efficiency because it is digital. So, like I said, to the best of our knowledge, it is the most advanced phased array system in the world. So that's pretty cool. We also have the advantage of a launch system that is capable of a very high launch rate and capable of putting a lot of mass to orbit. I believe last year, SpaceX delivered about 2/3 of all payload to orbit. And this year, we may deliver closer to 80% of all payload to orbit of Earth. Mm-hmm. Just with that, so, and of the remaining, of course, it remains to be seen for this year if we actually put close to 80% of all payload to orbit. But of the remaining, let's say roughly 20%, about 12% would be China or thereabouts, and then 8% is everyone else. So the sheer mass to orbit capability of the Falcon 9 rocket is, because it is a reusable booster and the fairing is reusable, so we only have to make the upper stage, that has never existed before, and the cost of mass to orbit also is the lowest it has ever been. So because of reusability, so this is the two work together quite well. But it has been quite an adventure learning how to make these advanced satellites and learning how to make so many of them, and the user terminal and the gateway. And the satellites, for example, use a SpaceX developed Krypton Hall effect thruster, which basically shoots out high-speed ions of Krypton. It's kind of cool. Superman, watch out for our satellites, don't go close to them.